Right, in Year 12, I want to go over some of the questions we did in class today. The main one I want to look at is something from the prelims called an offset survey or traverse survey. And I want to look at question 3 from exercise 5H. And we're going to do it with a couple of other steps as well. We're not just going to do the 3 parts that they've got here because I think it's important we do some other ones as well. So this is an offset survey. And what happens is you go out in the field and you measure a straight diagonal on a block of land, and every time you see a vertice or a corner, you take a 90-degree offset measurement of that distance. And what you'll do is you'll get your straight line from A to D in this case, and you'll get your offsets. Well, there's a line off to C and there's a line off to B. The reason that we need to do question 3 is because it's a little bit different from these ones in questions 1 and 2 because they all end up being triangles. And what will happen in the HSC is you will get one that has triangles and maybe a trapezium. So this question here, this offset field book sketch here for this offset survey is important. So let's have a look at what we do. Now the first thing, always, if you've got time, do a quick sketch. So I'm going to draw this and I'll try that again. So I need a straight line going up. There's my straight line going up, and that's going to be my measurement from A to E. And then I have these offsets coming up. Now the first one is about, let's put it about there. It's 14 and it's 25 up. Actually, I might move that. I can't move it now. I might try that again because it doesn't look to scale. Even though we don't want to be too pedantic about it, we want to get the right amount. So 14. I'm going to go and grab this. And if it's 25 up and 14 across, let's go about there. The next one is 23 and 34 across. So let's get this one again. And it's a bit longer. Oh, goodness me. And I haven't drawn that very well, but it doesn't matter. I'm going to stick with it. It's too difficult to get it back down. And this one, I'm going to have to go right over here. So I'm going to have to, and it's at about 58. So it's, well, that's no good. Let's undo that and try that again. And it's 43. And I'm going to do this freehand now because it's just too difficult otherwise. Then we join the dots. All right, so I'm going to join them in red. And I know it's not accurate, but it's the best I'm going to do. And that's what it should come out. Remember, you would do it with a ruler and it'd be a lot neater. So let's put some things in here that we know. We know that this distance here is 23. We know this distance here is 14. We know this distance here is 43. Now we need to work out the distances going up. Well, the first one's pretty easy. That distance is 25. But this distance between this point and this point, we have to work that out. Now, we can see it goes from 34 to 25. So 34 minus 25, well, that equals 9. So that distance is 9. If we go between these 2 points, this one and this one, well, over here we can see it goes from 58 to 34. So 58 minus 34 is 24. And the last one here goes from 58 to 71. So 71 minus 58. And 71 minus 58 gives me 13. Now I've got my fieldbook sketch. I can find all the dimensions of things that I need to find. So the first thing it tells me is to find the area of this thing. Well, there are 4 areas. There's this big triangle here. Actually, I'll put the letters on first. So we've got C here, B here, and D here. So ACE, this bit here, is one big triangle. So I'm going to call that area 1. Up here is another big triangle. Another triangle. I'm going to call that area 2. This bit in here, that's a trapezium. So I'm going to call that area 3, but that's a dangerous one. That's a hard one. And down here, I've got another triangle, area 4. So let's work them out. So the first one, area 1, that's one big triangle. So it's a half. Now the base is all the way from A to E, and I already know that. That's 71. So it's a half times 71 times the height, and the height is here on that offset bit. That's at 23. So a half times 71 times 23. And if I go into that, I get 816.5 meters squared. Area 2. Well, again, that's a triangle, and I've got the dimensions on it already, so it's just a half times 13 times, let's have another look back, 43. So 0.5 times 13 times 43, 279.5. I'm going to jump to area 4 because it's a triangle as well, and it's pretty easy. So half times, and the dimensions are on here as well, 14 and 25. That's 175. Now the difficult one, this trapezium here. Now remember, you have the formula for a trapezium on your formula sheet, and it's given as h on 2 a plus b. Now you've got to remember this trapezium in here, your height is this distance, and that's your A, and that's your B. They're the parallel sides. So the parallel sides are easy, but the height equals 24 plus 9, which is 33. So now we put it in. So we get 33 on 2 times 43 plus 14. So 33 divided by 2 times 43 plus 14. We get 940.5. Now, the total area, I'll just add them all up. So 816.5 plus 279.5 plus 175 plus 940.5. And I haven't got the answers in front of me, but we did this today in class, and I'm pretty sure this was the correct answer. Now, the second part's asked for the distance of AC, and we did this in class, and it's pretty easy. Let's have a look at AC. AC is this distance here. And it's pretty easy because what we have is a right angled triangle. And I can just, there's the right angle, and I can just use Pythagoras. Now one side is 23, but the other side is not that easy. It's 9 and 25. So that distance, 9 plus 25 equals 34. So I go down here now and I say, all right, well, AC equals the square root. Okay, what were the distances again? 23 squared, because we're using Pythagoras, plus 34, which we just worked out, 34 squared. Now, I didn't really need to work that out because look, it's over here. There it is, 34. Anyway, so I do that, square root of 23 squared plus 34 squared. And I get 41.05. But they say to the nearest metre, so 41 metres. Now, I want to look at a question that you'll get in the HSC that's not part of it, not part of the questions that they asked. I want to find the distance dB. So I'm just going to erase some space for me here and calculate the distance dB. So dB is this distance here. Now, how am I going to work that out? Well, let's get rid of some other things in here and have another look at this diagram. Now, if I draw a line straight up from here, I get a nice right angled triangle in here. Now, I already know this distance from up this straight line because it's 24 and 9, and we already calculated that, 24 and 9, so that's 33. But what about this distance here? How do I work that distance out? Well, I know it's 43 all the way, and I know it's 14 from here to here, so I'll just go 43 minus 14. And I get 29. So that distance is 29. Now it's easy. Now I just go BD by Pythagoras equals the square root of 29 squared plus 33 squared. And the square root of 29 squared plus 33 squared is 43.93 meters. Now that's not part of the questions that they asked, but that is one that you will definitely see in an HSC and that we're going to have a look at some of the examples tomorrow. So remember, for an offset survey, a quick sketch from the field book sketch, a quick neat diagram, and be careful when you get a trapezium, because a trapezium, the area formula is difficult, and finding the distance means you've got to do a little bit of maths by creating a right angle triangle on it. Anyway, good luck, and I'll see you next lesson.